Welcome to Geek Do-It-Yourself Mechanic. This video is the second of 3 videos to discuss concepts that can help you properly test an automotive sensor circuit. This particular video will address pull-up type sensor circuits. Let's review part 1. It discussed how to properly backprobe the sensor, testing powers and grounds, and testing that the sensor works correctly. For this video, we're going to assume there is some sort of error. For example, the scan tool is not displaying a different value even when we cause the sensor to change state. For example, pushing on the accelerator pedal since we're working with the throttle position sensor. In part 1, we demonstrated how to test the sensor. This video will discuss how to test the PCM sensing circuit when it is configured in a pull-up design. I have watched numerous Scanner Danner videos and have even interacted with Paul via video comments about some of the concepts about to be presented to you. My goal is to test the sensor line to the PCM voltage sensing circuit. Let's navigate to our demonstration circuit. Knowledge, electronics, testing concepts, 3-wire sensor. This should look familiar. Let's start by disconnecting the sensor. Since the sensing circuit is configured in a pull-up design, the voltage sensing circuit reads 5 volts, and it does. If you remember down here, this scope graph displays what the voltage sensing circuit is reading. Again, the reason it's at 5 volts is of the pull-up resistor, and there's no current flow. So there's no voltage drop, therefore 5 volts is all through the green here. Test A. 5 volts to sensing. Again, due to the pull-up circuit configuration of the PCM sense circuit, when we connect 5-volt reference line to the PCM sensor, the sensing circuit continues to read 5 volts. Also notice the current flow is represented as 0. Again, this is because the voltage sensing requires virtually no current. So let me connect 5-volt reference to the sensing. Again, there's no current flow, like I said, because the voltage sensing has very minimal current flow. But let's pretend the PCM sensor wire is somehow being grounded. For example, a hole in insulation that is touching the grounder frame. So I'm going to ground Once I connect the sensor line to ground, do you notice the current shoots through the roof? Current is at 5 amps. Whoops! Bad. We just shorted the PCM's 5-volt reference circuit. Not good. It is probably protected, but still, this is extremely dangerous. Don't do this. Instead, whenever applying the 5-volt reference to the PCM sensor line, use a resistor as a jumper. In this case, you notice I used a wire. Scanner Danner suggests using a 5K resistor, since this is usually the resistance of the sensor. In other words, that's usually the load on the circuit. Therefore, it's probably set up to handle that load. Let me show you how the circuit behaves differently when jumped with a resistor versus a wire. Using this technique, you can perform the same test but in a safe fashion. This test allows you to determine if there is a short between the PCM side sensor and the PCM, to the PCM. If the scan tool still reads 0, you have a short in the PCM sensing line, since you know that it should read 5 volts. And we do. And it is reading very close to 0. It should be 5, actually it is 0 to 1.5 millivolts. So again, we should have seen 5 volts on the sensing circuit because we're applying 5 volts to the sensing circuit, but we don't because there's a short to ground. And this is what the test would look like if it was successful. We connected 5 volt reference to the sensing circuit via 5K resistor, and we see 5 volts on the scan tool. Test 2. Taking the 5 volt reference to PCM ground tests nothing. It actually causes a short to ground, and therefore this shouldn't be done. So what I'm saying don't do is don't connect 5 volt reference to ground. So please read your wiring diagrams carefully. But just to see what happens, let's connect the 5 volt reference to the PCM sensor ground, as I did. Oops. Notice the current reading? 5 amps. We just took down the PCM's 5 volt reference circuit to ground. Not good. The PCM's 5 volt reference circuit is probably protected, but this is extremely dangerous. Don't do this. So let's not. Let me get rid of this thing. Test 3. Ground to sensing. Since it's a pull-up design, taking the PCM voltage sense circuit to ground will allow you to determine if the PCM detects change. Right now it displays 5 volts. We need it to change from there. Let's take the voltage sense to ground. Exactly what we thought would happen. The PCM sense voltage goes to ground. After taking the voltage sensing to ground, the scan tool should appropriately display a value very close to 0 volts. In this case, ours would. If this occurs, you have just verified the signal line to the PCM is good, and the voltage sensing circuit in the PCM is functioning properly. Now, let's run some tests with a test light. The first 3 tests will be performed with the test light connected to battery positive. This is our test light connected to battery positive. This is the test light connected to battery negative or ground chassis. Test 1. Positive test light to 5 volt reference. Applying 12 volts, remember this is connected to battery. Applying 12-volt test light to the 5-volt reference line could cause damage. In my humble opinion, this could cause unpredictable results, since the circuit's response to this is dependent on 5-volt reference circuit design. What I'm trying to say is, we just made the 5-volt reference jump to 12 volts. Your sensors could get damaged, and we know the readings will be off the chart. Because remember, they're going in reference to 5 volts. They're pulling it down or up to 5 volts. Now it's at 12 volts. In any case, don't do this. In addition, this test makes no sense. Test 2. Positive test light to ground. Applying the test light to the connected ground turns on the light and ensures that the connection truly connects to ground in some fashion. Test 3. Positive test light to signal line. The scan tool should already be reading very close to 5 volts, and it is. Applying the test light to voltage signal line makes the PCM register 12 volts. Yet the scan tool will probably still display 5 volts, since the software limits the value to 5 volts for display, or the voltage sensing circuit may cap at 5 volts. We don't know, but nonetheless, most likely what's going to be displayed is 5 volts. In theory, since the voltage sensing circuit draws very little current, this test should be safe. Scanner Danner does this test all the time. The following 3 tests will be performed with the test light connected to battery negative, chassis, or ground. So we're going to use this test light. Test 1. Applying test light to 5-volt reference turns on the light. Let's do it. The current draw should be very low and not cause any issue. 125 milliamps, if you notice at the bottom there. But if I wanted to verify the 5-volt reference, I would use a DVM or a scope meter, which allows me to ensure the voltage is clean and stable. I want to see that line on my scope meter nice and flat. Test 2. Negative test light to ground. Applying the test light to connector ground does nothing, since ground is being connected to ground. This particular test accomplishes nothing. Test 3. Negative test light to signal line. Applying the test light to the signal line makes the PCM register 0. The scan tool should display 0 volts at this point. When this result occurs, you know that the signal line has no issues. This concludes our test for the pull-up sensor circuit design. I invite you to visit this webpage and play with this circuit as well. Perhaps trying this circuit and seeing what happens. Again, you should always avoid allowing current to go straight to ground without going through a load first. When this occurs, it is referred to as a short to ground, which could cause irreparable damage. For more information on this topic, please refer to the suggested readings. Thank you for watching. I hope you found the information helpful.